Hello everyone. Now we are going to see the very important topic in organic chemistry, that is Markovnikov's rule. When the Markovnikov's rule arises, when we have a symmetrical alkene like CH2 double bond CH2, when the alkene is added to any protic acid like HBr, where the H plus will go and where the Br minus will go, there is no struggle at all. Now, if the protic acid approaches the alkene, the double bond will have one pi bond. The pi electrons may move to carbon, any of these two carbon, because when it moves to any of these carbon, it is going to attain same intermediate. Like if it moves, you consider this carbon to be number 1 and this carbon to be number 2. Okay, you consider when the pi electron moves to number 1 carbon, it will attain carbon negative charge. Then this carbon will have positive charge. Then now we have H plus, it will automatically go to carbon minus, and when we have Br minus, it will go to CH2 plus, so that it is to give CH2 H attached here, and we have CH2 Br attached here. This is number 1 possibility. So you consider the another scenario when the double bond moves to the second carbon, then automatically this carbon will have positive, number 1 will have positive and number 2 will have negative charge. Now the reaction will be the Br will go to positive charge, the hydrogen will go to negative charge. Now when you name this, we are going to get both the product as a 1 bromo ethane. Similarly, when we move to this compound, whatever we obtained from the second scenario, we are going to get same 1 bromo ethane. So in both the cases, we have only attained same compound. In the previous case, we have seen about a symmetrical alkene. Now we take the example for unsymmetrical alkene. Consider CH3, CH double bond CH2. So how it is to be considered as a unsymmetrical one? When you keep a mirror at this double bonded carbon, when both the sides are similar, that is to called as a symmetrical. And when you keep the mirror when both the sides are not same, okay, that is called as a unsymmetrical alkene. Now the real problem exists here when you add HBr, any protic acid like HBr, HCl. When you add these two, any of these two acids, where the H plus will go, where the Br minus will go. The real problem only exists here. Let's see how the mechanism is going to take place and what are the possibilities are going to be. You consider first pi electrons move to the number 2 carbon. Okay, so in this case, whatever the intermediates are formed, CH3, CH minus, this carbon, the number 1 carbon is going to CH2 plus. In the second case, you consider this as number 1 and this is number 2 case. When this pi electron moves to number 1 carbon, the intermediate formed is CH3, CH plus, CH2 minus. See, when you consider the stability of carbocation, the tertiary will be more stable than secondary than primary. When you consider the stability of carbanion, the order is reverse. The stability of carbanion here, the first will be primary, then secondary and then tertiary. Now with this knowledge, let us analyze whatever the intermediates are formed in the first case and in the second case. You consider first, you analyze the number 1. So here carbocation, whatever is formed is primary, whereas carbocanion formed is secondary. When you go to the second case, whatever carbocation formed here is secondary, carbanion formed here is primary. Now, according to this, whatever results we have obtained here, you analyze here carbocation here is primary, whereas here secondary. So as when you come to this case, carbocation, secondary is more stable than the primary. So that the first preferred path will be second one. So now, according to this, the hydrogen will go to where the carbanion is formed, and Br minus will go to where carbocation is formed. Okay, so the most preferred major product will be CH3, CH, Br and CH2, the newly joined hydrogen. So whatever you obtained here, 2 bromo propane. Okay, now if you want to answer very quickly for the reaction, as soon as seeing the compound alkene itself, okay, if you find that the given compound is unsymmetrical alkene and you are given with the protic acid HBr, so the whatever compound will be formed, very simple way to understand, where the carbon along the double bonded carbon, where the carbon contains more number of hydrogen, the hydrogen will get attached to that particular carbon. So in a simple way, the rich becomes richer. So the same can be applied here, where the hydrogens are more in the particular carbon, that will attract the H plus, and Br will go to the secondary carbon. Okay, so I have given very simple compound. As length as you are writing, you just remember only one rule. If it is a symmetrical, you don't have to go for Markovnikov's rule at all. If it is unsymmetrical, then the unsymmetrical alkene, you should immediately remember Markovnikov's rule. You just divide the compound where the along the double bonded carbon, where the hydrogen should go, where the number of hydrogens are more in that particular double bonded carbon, there the hydrogen get attached. Okay, thank you.